Hi! So today in this video we're going to be talking about chapter 2.1, which is functions. Again, I will say, as in other previous videos, for 1050, all of the problem numbers are going to be different, like the values. Hopefully I'll have access to the web assign so I can copy and paste pictures instead of trying to look at the book, because it's kind of a pain in the butt to do it this way. But for now, we'll just work on this. Let's hop right into it. This is 2.1, which is functions. The first couple of problems that we want to do is evaluate. So what we can do is we can say, okay, we have this f of x, and we have this. What happens if we replace this x with a 2 in our function? This is our function, and we want to replace the x's with 2's. So what we'll do, so for f of negative 2, let me make a smaller brush. That will be equal to negative 2 squared plus 3. Now these parentheses are important. It's really good practice to use parentheses when you're plugging things in. And so this will turn into positive 4 plus 3, which is 7. Same for positive 2. It'll be 2 squared plus 3, which is 4 plus 3 equals positive 7. For 0, we'll just plug a 0 in for x. So 0 squared plus 3 is equal to positive 3. And then for 1/2, it's the same. 1/2 squared plus 3 is equal to 1/4 plus 3, which is the same as 3 and 1/4. Awesome, easy peasy. And this next one has a few more complicated examples as well as 2 x's. So let's just hop into it. We are going to start with f of 2. So it'll be 1 plus 2 over 1 minus 2, which is the same as 3 over negative 1. So negative 3. F of a will be 1 plus a over 1 minus a, which this is as simplified as it can go. F of 1/2 will be 1 plus 1/2 over 1 minus 1/2, which will be 1.5 divided by 0.5, or however you'd like to write it. You can write it however you want, at least in the homework assignment. I don't think it specifies whether it wants it in fractions or anything like that. You could do 1 and 1/2 or 3/2 over 1/2. So 3/2 over 1/2. This would be the same as 3/2 times 2 over 1, which will give you 6 over 2, which will give you 3. So 1/5 over 0.5 is equal to 3. So your 1/2 will be equal to 3. And then for the a minus 1, we'll do 1 plus a minus 1 and 1 minus a minus 1. Now this minus sign has to apply to everything inside the parentheses. So it'll be a, so it'll be 1 minus a on this bottom, and then 1 plus, and then plus 1 instead, because that parentheses switches the signs. These parentheses technically are not needed because you don't need to multiply by anything. So this would be, and then you could combine these. So it would be 0, so it'd be a over a, which is the same as 1. I'm not sure if your example will be like that or not. And then x squared plus 1, we have 1 plus x squared plus 1 over 1 minus x squared plus 1. This is the same as 1 minus x squared minus 1. And then this can be x squared, and then 2 plus x squared plus 2. Now, the first response that people tend to have is they want to cross out these x squareds, but it doesn't really work like that. We can just keep it like this. Yeah. This one is a piecewise function. We want to find out what the values are when we want to find out what the value of the equation is when our x value is equal to negative 2, positive 1, 0, and positive 2. But we've got a little bit of a puzzle here. It's sort of like paint by numbers. So first let's look at negative 2. 2x squared, if x is greater than 0. Is negative 2 greater than 0? No, so we are not going to be using this one. Is x less than or equal to 0? Yes. So we will use x plus 3 one. So for f of negative 2 equals, it will be negative 2 plus 3, which is positive 1. For f of 1 is greater than 0, so we'll do the 2x squared one, which will equal to 2. F of 0 0 is equal to 0, so we'll use x plus 3 one. That will give us is equal to positive 3. And then 2 is greater than 0. So we'll do the 2x squared one, which will give us, here, hold on, sorry. F of 2 is equal to 2 squared, which is going to be 2 times 4, which is going to be 8. And so these would be all your answers. Be careful when you're plugging stuff in. Net change. What is the net change from 3 to 5 with the equation negative 5x plus 4? So what we'll want to do basically is to calculate these values and then find the difference basically. So we'll do negative 5 times 3 plus 4, which is negative 15 plus 4, which is negative 11, 2, and then from 5, negative 5 times 5 plus 4 is equal to 20 plus 4 to 24. Oh, sorry, my bad. Nope, not 24. Because this will be negative 20, which will be negative 20 minus 16, so negative 16. It looks like the net change is going to be 5. Let's double check on this. It could be negative 5, because I know that it likes to, I have to double check on this. Yeah. Around 39. Let me pause real quick. Okay, yeah, so it'll be negative 5 in this case, because we're going negative 5 spots. Find the difference quotient. So this is a new term that you probably have not heard of in 1010 or 1015. But basically what we want to do is we need to find f of a and then f of a plus h for the equation of 2x plus 3. So we already know, like in previous examples, how to do this. We know that we can do 2 times a plus 3. So f of a is the same as 2a plus 3. And then f of a plus h is going to be 2 times a plus h plus 3, which will give us 2a plus 2h, because we have to distribute, and then plus 3. So this is our first answer. F of a is equal to f of a plus h is equal to. Now we need to find this. We've already found f of a plus h, so we'll put that in front. F of a plus h is equal to 2a plus 2h plus 3 minus f of a, which is 2a plus 3. I'll divide by h, but we don't need to worry about this for a second. Let's combine like terms. One thing. This minus sign goes around all of f of a, so we need to distribute. So we'll have minus 2a minus 3 instead. That's a mistake a lot of people do, and I almost just did, even though I'm aware that it's a mistake. So we'll get rid of this negative 3 and this 2a. These will cross out, leaving us with 2h over h. These h's will cross out, leaving you with 2. 2 is your answer for that question, but not yours. Yours is probably going to be a little different. We want to find the difference quotient for f of x equals 3. This one is a little bit silly. People are like, well, I don't know what to do here. But it's actually it's as simple as it seems. F of a is going to be equal to 3. F of a plus h is going to be equal to 3 because there's no x's that we're plugging these into. And so now we can do f of a plus h, which is 3, minus 3 over h. So you'll have 0. Your answer is 0. For that one at least. And then this one, f of a is going to be equal to a over a minus 1. F of a plus h is going to be equal to a plus h over a plus h minus 1. And a lot of students' first impulse is to cross these out, but it doesn't work that way because there's these tricky plus signs. So now what we can do is we can combine everything. So we have a plus h over a plus h minus 1 minus a over a minus 1. Now what we can do is, and then all of this is over h. Now I'm not sure how far they want you to simplify this, so let me double check really quick. Okay, let me just try something real quick. Let's ignore this h for a minute, and let's try to do this operation. We need the same denominator if we want to be able to combine them. So this one's missing a minus 1, and this one's missing a plus h minus 1. So what we'll do is we'll multiply this side by a minus 1 over a minus 1. This is allowed to do because a minus 1 over a minus 1 is the same as 1. And so we're not changing the actual value, we're multiplying by 1. So a plus h minus 1. And then similarly, on this side, we'll do a plus h minus 1 over a plus h minus 1 times a over a minus 1. And what will happen is we'll FOIL. We don't really actually need to FOIL the bottom. We can just leave them like that. So it'll be a minus 1 times a plus h minus 1 minus a plus h minus 1, a minus 1. So now they have the same denominator. What will the top of this one be? Let's see. A squared plus AH minus A minus H, and then minus A squared plus AH minus 1A. All of this is still A over H, but we don't need to worry about that for a minute. Now we can combine like terms, but first let's, we can focus on the top for a minute. So what will happen is we'll have A squared plus AH minus A minus H minus A squared plus AH minus A all over A plus H minus 1 and A minus 1. Now what we can do is distribute this negative, so it will be minus A squared minus AH plus A, and no more parentheses. Now we can combine like terms, so we have a minus A squared here, minus AH and a plus AH, plus A and a minus H, which leaves us with negative H over A plus H minus 1, A minus 1. This is kind of a gross problem. All over H. Now, what we can do, I just brought this over H back. We were ignoring it for a minute, but now we're back. Now what we can do is negative H over A plus H minus 1, A minus 1 times 1 over H. Now these will cross out, but we'll keep the negative, so it will be negative 1 over A plus H minus 1 and A minus 1. Pretty gross if you ask me, but it's okay. We did it. Let's move on. We want to find the domain of this equation. To find the domain, basically what we're saying is what all of our x values are. And we kind of assume default that we're starting with negative infinity to positive infinity. But there are a few things that we cannot have. We know that we cannot divide by 0. That's not allowed. And we also know that anything inside of an even integer index, so like 2, 4, 6, 8, this has to be greater than 0, because we can't have any negatives in there, but it can be equal to 0 though. That's allowed. And then technically later on when we get to logarithms, whatever's inside the logarithm has to be greater than 0. But I don't know if we have any log examples. Anyway, moving on. We don't need to worry about this top unless it's one of these examples. In this case, it's not any of these examples. So what we can do is just worry about the bottom. We don't want the bottom to be equal to 0. So what we have is x squared minus 2. Let's set it equal to 0 so we can find what makes it 0. We'll add the 2 over, so we'll have x squared equals 2. Square root both sides. We'll get x is equal to plus or minus the square root of 2. I'm fairly sure yours will be a nicer example. I'm pretty sure it's a 1. So x cannot equal plus or minus the square root of 2. Now with that, I'm not sure if it wants you to write it in domain, in interval notation, but let's do that just for practice. We know that it's going to have some gaps here. So what's going to happen is we can do for domain, it will be x not including negative infinity, because that's our smallest value, to negative square root of 2, not including, and negative square root of 2 to positive square root of 2, and I'm running out of room, I don't want to cut into that problem, and this positive square root of 2 to positive infinity. That would be your domain. What's the domain of this? This one, again, we don't need to worry about the top since it's none of our examples, but this one we actually have two problems that we need to worry about, both the square root and the denominator being equal to 0. So first, let's just set it equal to 0. So square root of 3x plus 4 is equal to 0. We can square both sides, which gives us 3x plus 4 equals 0. 3x is equal to negative 4. X cannot equal negative 4/3. So that's one of ours. And then we need to be greater than or equal to 0. So equal, we'll change this into the greater than or equal to 0 because we want the inside to be the same. So since we are not dividing by any negatives, we can just keep this sign the same. If we were dividing by negatives, then we would have to change, but that's not happening in this equation. We'll probably go more into that later on. But yeah, so x has to be greater than or equal to negative 4/3. But it can't be equal to, remember, because that turns it into 0. So it's just going to be greater than. So our smallest value is going to be negative 4/3. And our largest value is going to be positive infinity for our domain. And both are not included. If it was not on the denominator, then this would be included. Like if it was just f of x equals 3x plus 4. But since it's on the denominator, it has to be not included since it turns into 0. Now these two problems are crazy big word problems. And let me just read it to you real quick. According to the theory of relativity, the length of an object is a function of its velocity with respect to an observer. For an object whose length is at rest 10 meters, the function is given by L of v equals 10 times the square root of 1 minus v squared over c squared, where c equals the speed of light, which is 300,000 kilometers per second. A is asking us to find some values, and then B is asking us how does the length of an object change as its velocity increases. Basically, what it's asking for A, we just need to plug some values in. Give me just a second. For 0.75, we'll do 10 times 1 minus 0.75 C, and I feel like it probably does definitely want our kilometers per second, and then over. But let me double check on that because actually things might be weird. Let me open this up. Okay, I have a feeling. I'm going to pause and solve this a little bit and see if play around a little bit. Okay, so for L of 0.75 C, that will be equal to 6.6. For the C, you definitely do want to plug in the 300,000 kilometers per second. So, and then for the 0.85, that's easy once you have the original. You can just replace the 75 with the 85. That gives me 5.267. And then for the 4.4, that gives me 9.165. And I kind of wrote it really weird, but technically it goes from 9.165 from slowest to 6.6 to 5.267. How does the length of an object change as its velocity increases? It looks like the length of the object actually gets shorter. So since these are bigger velocities and these are the lengths, since we know that it's solving for the length when we plug it into our formula, it gets shorter. Awesome. So it's a really intimidating looking problem, but it's actually simpler than you might think. Because of the curvature of the Earth, the maximum distance, d, that you can see from the top of a tall building or airplane at height, h, is given in the function. D of h is equal to 2rh plus h, and that's the square root of that. Where r is equal to 3,960 miles is the radius of the Earth, and d and h are measured in miles. Sorry, I'm so stuttery today. Find d of 0.3 and d of 0.1. How far can you see? So this one we can just plug in some values. So the square root of 2 times r, which is 3960, times h, which is 0.3 in this case, and then plus 0.3. Whoops. Also, this is h squared, not just h. I, for d of 0.3, I'm getting 48.745, give or take. How far can you see? Oh, and then the 0.1, hold on. 0.3, 0.1 instead. 0.3, 0.1 instead. For 0.1, I'm getting 28.14267. Oh, whoops. Whoopsie. 28.14627. We'll just like round it. Yeah. So, and then how far can you see from the observation deck of Toronto's CN Tower, which is 1135 feet above ground? Let's see. This time we're going to switch to hold on. Boop. So, this one is 1135 feet. To find this in miles, because it's going to be our height, we want to divide it by 5 to 80, 5 tomatoes, which is the feet. How many feet are in a mile? So 1135, divide by 5 to 80. 1 second. 1135 divide by 5 to 80 is 0.21. So we'll do 0.2149.6, and then 0.21496. That gives me 41. Hold on. Oh wait, whoops. Yeah, 41.26, which can be rounded to 41.3 miles. And then for C, which is what about 8 miles, what we can do is just plug in 8 to our equation instead of having decimal points. So it'll be, I'm doing this all on my phone calculator. Sorry, I can't do it on the screen. Which will be about 79, we'll round up to 80 miles. It's 79.6 miles basically, so. And then net change of value and distance as h changes from 135 to 8 miles. We can take our 135, which is 41.3, and then we can take our 80 and we can minus them. 135 to 8. And that will give me 80 minus 41.3, which is 38.7 miles. Awesome. That was a very long video. I hope that's okay. If you have any questions, please let me know and I'll answer as soon as I can. Have a good one.